Hello, we continue to practice solving problems with algebra. How do we do it? We translate English. The word problems are in English and we translate them to algebraic expressions, algebraic phrases. So let's read the first question number 4. We are in question number 4. A postage company sells 27-cent, 42-cent, and 59-cent stamps. So what is the problem talking about? We are talking about slightly cheaper stamps, right? Let's write them like this. Smaller ones, 27. Imagine these are like little stamps. And then, of course, we're talking about medium price stamps, 42-cent stamps, right? Let's make them a little bit bigger, right? 42-cent stamps, something like that. And finally, we have very expensive stamps. Maybe we use them for sending letters abroad, right? And they cost even more. They are 59-cent stamps. So that's what the post office sells. 3 types of stamps. Mr. Taylor buys X 27-cent stamps, Y 42-cent stamps, and Z 59-cent stamps. Now, the problem did not tell us how many of each type did he buy, right? We know that there are multiple stamps, ... and so on. How many exactly? We have X. Now, we also know that not one, he bought, more than one of 42-cent stamps, ... How many? Y. The quantity is Y. And finally, we know he did not buy 1 or 2 or 3 or 5. We know he bought ... Z. The number of 59-cent stamps is Z stamps. So, how much does Mr. Taylor have to pay for all of his stamps? Look at what they're asking again. Write an expression. Express the answer in terms of X, Y, and Z, meaning translate English into algebra and answer as an expression using variables X, Y, and Z. Well, let's break this problem into steps. Always. Let's break it into steps. Step 1. What is the total amount of money Mr. Thomas spent on his cheapest stamps? 27-cent stamps? It's 20. Let's use the same color, of course. He spent 27x. That's the amount of money. What about 42-cent stamps? Right? Second step. Finally, we'll do that. He spent 42 times the quantity. Y. 42y. And finally, he spent 59z. That's the number of money, cents. We can write cents, but we don't have to, on his most expensive stamps. The question is, how much did he pay altogether? Let's add all of this up, and we would have an expression. The expression would be 27x plus 42y plus 59z. That is the algebraic expression. Now, what do we do with this expression? Well, we can solve different cases, right? We can solve cases. Look at that. If, part B, if x equals to 4, y equals to 5, and z equals to 3, how much does Mr. Taylor pay altogether at the post office? Let's substitute. We've used this mechanism before. X, in place of x, we would write 4. In place of y, we would write 5. In the place of z, it's called substitution. We can test different scenarios. If x equals 4, what if x equals 40? Right? Substitute the values in place of variables. Remember, variables are like buckets, placeholders for different constant numbers. So we can feed x equals to 4, x equals to 440, and so on. So again, step by step, but I'm just going to write it all together. I'm going to write it as a single expression. So I'm going to say 27 times 4 plus 42 times 5 plus 59 times 3. And I hope you do the math and you can find the answer on your own. Now, practice C. Let's consider additional problems. There are X girls and Y boys at a school. Do we know how many? No, X and Y. Each girl has 4 buttons on her skirt. Oy, so silly. 1, 2, 3, 4. And each boy has 5 buttons on his shirt. 1, 2, 3, 4, maybe 5, something like that. What is the total number of buttons? So, one girl has 4 buttons. X girls, 4X. One boy has 5 buttons. Y boys is 5Y. How to write it as a single expression? Just like that. 4X plus 5Y. Express, right? So we wrote an expression. We translated English into algebra. Problem number 2. There are 360 fifth graders and 440 sixth graders at a school. Each fifth grader has X books, and each sixth grader has Y books. What is the total number of books in terms of X and Y? Well, one person, right? One person in fifth grade has X books. And one person in sixth grade, right? Let's make that person a little bigger, equals, it has Y books. Well, what about 360 fifth graders? They would, of course, have X times 360, but in language of algebra, we would write 360X plus 440Y. And as a single expression, we would write it 360X plus 440Y. Just like that. Problem number 3. Larry bought X books, Y files, and Z pens from a school supply store, from a bookstore. Each book cost $10. Each file cost $5, and each pen cost $2. Instead of doing these bar models, I typically set up that problem like this. I say given. That's always a good practice. That what do we know? That one book, one file, and one pen, right? Let's write down what is given. One book is $10. One file is $5. One pen is $2. That is what is given. Now, how much of each supply did Larry buy? Well, he bought X books, he bought Y files, and he bought Z pens, right? Like that. So it would be 10 times X, $5 times Y, and $2 times Z. Now look at the question. Express the answer in terms of X, Y, and Z. This simply means translate this into algebraic expression. Let's write it down all together. He would have 10X plus 5Y plus 2Z supplies all together. Let's look at problem number 4. Mrs. Fernandez bought 40 notepads, 15 markers, and 20 pencils from a school bookstore. Each notepad costs X dollars. Each marker costs Y dollars. And each pencil costs Z dollars. I would write it like this. Given. Notepad, marker, and P for pencils. Notepad costs X dollars. Marker costs Y dollars. And each pen costs Z dollars. Now, what is the question? How much did the items cost in all in terms of X, Y, and Z? Meaning express, write an expression for the total cost. Well, we know she bought 40 notepads. So altogether, the notepads would cost her 40 times X. We know that she bought 15 markers, right? We can write here 40 notepads, 15 markers, and 20 pencils. So we can say she spent plus, and she also spent 15 dollars on markers. Plus, she spent 20 dollars on pens. And here we go, my friends. This is the expression. This is the expression. We just translated English to algebra.